Ooh, oh, what's this? Oh, wow. This is totally different than what I was expecting. Hey everybody, it's Ben here, and today we have in front of us a electric heater from a 2012 Chevy Volt plug-in hybrid electric vehicle. So this is what creates cabin heat when you're just driving along in the electric mode on the battery pack. You can see there's an input and an output on the two ends, and it basically works very similar to a home electric water heater. It's high voltage, so we've got pack voltage comes in here. It's resistive. It heats up the inside. Coolant gets pumped through, and that's how you get your heat. If you're particularly interested, here is the actual part number. Freeze frame it if you want to read that. But what I'm interested in is this thing is broken. I pulled it out of the car, which was a ton of work. It's just a tremendous amount of work to pull this out from under the hood. But if you look across the top here, see how this has a wet look to it? That is actually where the heater failed. So there's sort of a, you can even see like some drip marks coming down the front. That's how it was when I pulled this out of the car. So what I'm going to do is I'm going to show you how this failed. So we're going to get the get this out of the way. And what I'm going to do is bring out a air compressor. Okay, and before we do that, here's something else I thought was interesting, and that is you can literally see straight down the barrel of this. It's a straight shot all the way through the heater. I wasn't expecting that. I was expecting like a serpentine pattern, something like that, kind of give more time and space for getting heated up. The other thing, and it's going to be very hard to light this, is in here, this is a port for a temperature sensor, and you can just barely see. It's got a little bit of a rubber seal, kind of an O-ring. And so what I am going to do here is I'm going to put a cork in either end and just jam that in place. And I have my air compressor hose with just, you know, this is just like your typical blow-off tool sort of a thing. And the tip of this does fit inside here so that I can push it in place, put some air into here while holding the corks in. But before I do that, what I'm going to do here is, let's see what we can do here. I've got a little soap. So I just want to see if maybe I can put a little soapy water on here. Okay, let's see what happens here. So kind of right there you can see that rubber seal, sort of an O-ring. So I should be able to just shove the nozzle of the air sprayer right into there. Okay, let's see if we can get this to go this time. Corks in the inlet and outlet. I'm going to put some air in here. Take a look up here. So you could see how there was air coming out along that upper seam. So this thing is broken, and really the big deal is that it's like a busted seam up here. Don't think there's any way of fixing that. Looks like the whole thing is kind of pressed together. But I thought what might be cool is take this apart, see what's inside. I didn't know what the best way to open this up would be, but I do know that plastic cuts a lot easier than stainless steel. So I attacked the plastic portion with my angle grinder. A little bit of a mess. The plastic melts as easily as it cuts, but I was able to put 3 cuts across it, figuring I could stick a pry bar in there, pry it back, and get this thing open. Well, that's kind of cool. I mean, it looks like it's pretty open in there, which is something that we could tell, you know, originally being able to look straight down through it. So it looks like these bars here must be the actual heating elements. Coolant can just flow through right between them from one end to the other. Not a lot to it. Can't see anything else. But that's a pretty good amount of surface area, so you can transfer the heat pretty quick. It would be cool to get into that seam. I mean, right up here, that's where this failed. So I wonder what kind of gasket or seam or whatever there is under there. I guess I can just try to cut in here some more and then pry it. See if we can get a look that way. Oh, there is a rubbery gasket. Yeah. Right here. It's hard to hold everything steady and do this and look at the camera at once and everything, but you can see right here that is indeed kind of a rubbery gasket. So it looks like there is a gasket set into the stainless steel. I don't think I have enough material to pull that out yet. I'll have to do some more cutting. Not much to see in here. Ooh, oh, what's this? Come on. Ooh, 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 here we go. This seems like the exciting part now. Might have to get those two tabs off there too. Oh wow. All sorts of electronics in there. Very cool. Okay, this just got real interesting. Let's take off those last two tabs. Oop, okay, let's move this where we can get a better view now. Okay, so the whole heater, the top outside part of it is plastic that was put in place, stainless steel tabs bent over, and then connecting that is a rubber gasket under here. This is a very thick gasket, and boy, is that's really pressed in there too. Here's the part that I don't see anything I don't know. Looks like there's maybe like a little dried on, caked on something right there. Like this was like warped open, maybe. The other thing I'm noticing here too was the two bolts where the ground cables went. It looks like that actually holds this part together with the rest. Plug-in connectors. Wow, okay. I'm going to unplug what I can get at right here. Okay, so we can see where the wires, there's 3 wires. Well, 3 cables. This cable has 3 wires in it going to here. But yeah, that's the stainless steel case. And then this is the actual heater. Oh, okay. So we've got some sort of power switch anyway. So that would be for turning that high voltage power on and off very quickly. And what that would do would be, I'm pretty sure that's just pulse width modulation for varying how much current this thing's going to draw. I kind of love how like the inside is all milled, beautiful aluminum, and the outside is all like crap. Just looks like junk. It looks like these screws are T20. And they are not in tight at all. Very loose. No thread lock or anything. Well, I'm starting to see why this is a more expensive part than I would have thought. Ordering this through GM, over $1,000 for this. Little silicone bumpers, some sort there. It looks like I've got some sort of a hook here. It looks like that's part of the aluminum, and it snaps in place. Some insulating material here. Oh, right, so that would make sense for transferring heat. This appears just to be some sort of a silicone pad, probably as a insulative spacer. And this fiberglass or some other non-conductive material. And oh, there we go. These are a thin piece of stainless steel here. It's more insulating material. Ah! This is interesting. So it looks like we have four conductors. Oh, no, more than that. 4 pretty big size one little smaller one here, and then these others are just kind of brackets off of the aluminum plate. It's just plastic. Oh, got a board number in the corner here. It's kind of some sort of a board part number over there. Okay, I think these are connected to the circuit board, but not all the way down in. I think this whole board pops off these little guys. So it looks to me like there's prongs coming up from the aluminum block, male prongs coming up going into kind of a female connection. So I think this circuit board, these are power connectors down into the circuit board. And then the circuit board connects to prongs coming up from the aluminum block. So I think I can just pry this whole thing straight up. cool. Ooh, look at that. So it looks like these are the actual individual heating elements. And, oh, you know what? It looks like on the circuit board, this is part of the circuit board, but on almost all of these, that part of the circuit board came off and stayed down here. So all these little bits that came off should have stayed with that circuit board. Oops. All those. So I would bet each of these now individually slides out. And it seems like this is silicone to insulate one from the next. So it looks like there's these like individual kind of tubes these little heater parts are going down into. This is totally different than what I was expecting, frankly. I was expecting it was just going to be like a big, like a single heating element, and it's not like that at all. Okay, and we've got the ohm meter, multimeter set to ohms, and we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 individual little heaters in here. So let's check if we just check our resistance. (913 ohms, so a little less than 1 kilo ohm. (930). So anyways, there's 15 of them. They're all a little bit less than 1 kilo ohm each. Okay, I just got one of these doohickeys out, and the way I was able to do it was by just getting a grip on it with a good vice grips, really clamping it down, standing on it, and pulling it straight up. So, let's see what we got here. So it looks like this whole thing's held together by more of a silicone material. So current traveling from one plate to the other. And then, what are these? That, I don't know what it is, but it gets hot when you run electricity through it. I have no idea what that is. It's metallic, it's brittle. And basically it just had these conductive plates squeezed around it. So gosh, for the life of me, I don't even know what's like a most common material used for a heating element for something like this. But it's pretty strong. It's not too brittle. I can't break it with my hand. The other thing that's interesting is that there's so many of these in parallel that if one of these went bad, so what? You know, there's 14 others. Then also down in the hole here still, there's what I thought was maybe like a shim or something at first, but I don't know. Ooh. Well, that was interesting. Another piece of stainless steel. And this bottom part looks like it's separate. It's not part of the casting. but it seems like it's bonded in there pretty good. So I don't know, maybe the heating element gets shoved in there, and then that gets shoved in place to hold it in there nice and tight for a good contact fit. Not sure. Anyways, when it comes down to it, that's what's inside a Chevy Volt heater. And I think this thing, maybe I can polish it up. I don't know. Make an awesome paperweight or something, I guess. I hope you like videos like this. Please like, comment, and subscribe, and come check out more at 300mpg.org. Until next time, stay charged up.